Airplane mode. Hi, today we'll see powder metallurgy from manufacturing technology. Powder metallurgy from manufacturing technology. The powder metallurgy is defined as the art making objects, heat treatment of compressed metallic powders. Powder metallurgy includes the blending and mixing of powders, pressing or compacting the powder into the appropriate shapes, sintering the pressed powder compact, and perhaps the final sizing or finishing of product to meet the specific dimension tolerances. The process is applicable to single metal powder, to mixture of metals and non-metals. The operations of pressing may be carried out at ordinary or elevated temperature depending upon the compositions and properties desired in the product. Advantages. The advantages, the such parts which have the special properties can be produced which otherwise cannot be obtained. The machining operations are eliminated, the scrap losses are reduced by and often results in lower unit cost for given the part of comparisons to any other production method. Metals and alloys can be mixed together in any proportions which difficult in sometimes not possible by melting. Metal and non-metals can be fixed together in any proportions. There is a better control compositions and structure of component by this process. The article of any desired porosity can be manufactured. Super hard cutting bits and which can be never be manufactured by any other methods or made by the powder metallurgy. Example, sintered carbide satellites. This process is known as the this process is suitable for the mass production mass productions, and this is the uh, structure of the component. By this process, article of any desired porosity can be manufactured. Super hard cutting bits which can be manufactured by any other methods are made by the powder metallurgy. The process is suitable for mass production because the stroke of pressing and compacting the consist of press speed 60 strokes. The antification alloy strips made by the powder metallurgy can be made adhere to strong alloy backing piece. The process is very economical and loss materials is lesser is as compared to the other processes. Diamond imprinted to the cutting for porcelain of the glass, tungsten, and carbide are made possible only by the powder metallurgy. Disadvantages and limitations. The process has the following advantages owing to fairly the high competing and the pressures required to press the powder for the wear on the dies is high. Due to the high rate of the wear of dies, high cost for the dies and process, this method rendered uneconomically, particularly for the small runs, since compacted parts may be ejected for the without fractures of. Therefore, the shapes that may be made by this method are limited. The equipments are required for the very costly. Completely the product is not possible without heating the product after pressing the operations. The physical properties obtained by this process are lower than the obtained by the other process. In the low melting powders like tin, zinc, cadmium, sometimes certain thermal difficulties appear. Pressed and sintered powder approximately achieve the properties of wrought alloy, but at the cost increased production cost. The interest rate of the sheep cannot be made by compacting the since metal powders and cannot be closed like the fluid under the compact load. The products are small size because for large size the bigger equipments and tools will be necessarily involving very investment and many metals powders explosives at the room temperatures. Few metals cannot be compressed because they have tendency to cold weld to the walls of the die, causing the wear on the die. Application of the powder metallurgy, the porous graphite containing the metal and bearings, electrical contacts of which embedded the resisting particles, tungsten wires, diamond imprinted tools, refractory of the metal composites, motor brushes, metallic coatings, cemented carbides, rotor gear comp, magnetic materials, metal or glass seals, metallic filters, barbiturate bearings, and friction materials. Manufacturers of the parts by the powder metallurgy, the production of the metal powders, pressing compact metal powders, sintering, bending powders, finishing operations, the production of metal powders, optimizing electrolyte process, stamp and ball mills, mechanical alloying, gaseous reductions, carbonyl process, and granulation process, and the other process. The automation process. In this process, the metal is pushed through the orifice onto the stream high velocity of the mean inert gases cause extremely rigid cooling and disintegrations into the very fine powder. The use of the process of the usually limited to the metals with melting joint gaseous reductions. This process is consist of grinding of metallic oxide and finally divided in the state again and then reducing the hydrogen carbon dioxide. It is employed to the metals whose melting points near the 1100 degrees centigrade electrolysis process. In this process, producing the powders, conditions of electrode positions are controlled in such a way that the soft is spongy and deposit is formed, which is then pulverized to the form of the powder, and particle size can be varied over the wide range by varying the electrolyte compositions and various electrical comparators. The powders, copper, iron, and the other metals are made by this process. Carbonyl process. This process is based upon the fact that the number of the metals can be react with the carbon dioxide, known as the carbonyls. For example, iron carbonyl is made up of the iron reduce the ferric acid, the carbon dioxide with the pressure of the 48 to 200 bars passed over the heated iron. The result the carbonyl is decomposed by heating the temperatures of 200 degrees centigrade to 300 degrees centigrade. This process yield the process of the yield by yielding the powders of the impurities, but the entails a heavy cost. The stamp of the bill payments, the mechanical methods of produce the relatively coarse powder. The ball mill is employed for the brittle materials, ductile materials. This is the cost is usually the powder materials. The graduation process. The process consists of the formation of an oxides, the formation of the oxides, mechanical alloying. In this method, the powder Two or more pure materials mixed with the bell mill under the impact on the handballs. The powders are repeatedly fractured and weld together, diffusion, forming aligning the powder. Other methods, less commonly the methods used, the precision of the chemical solutions, the production of fine tools by machining, vapor condensation, new development include techniques based, and the temperature is exactly the metallurgical process. The metal powder or produced by using the temperature processing technique, the reaction of the volatile, the handles of the liquid metals controlled by the reduction of the carboxylation of the solid work. Composition of the solid work. The various forging techniques, cold forging, sizing, coining, cold beading, the cold beading, in the precision of the folding, special dies are made and machine grade accuracy than in ordinary impression of die forging. Choice between the combination forging, the precision forging requires an economic analysis of the precision forging requires the special dies, and however the much less machining is involved in the because the part of the chooser to desire final shape advantages. The part can be made with minimum draft and weight reductions, high strength and weight ratio. The surface finish is smooth. The lateral partitions undercuts can be produced without machining. Small edges are produced as forged parts. The control parting placement provide the most desirable flow of the metallurgical properties. Some seamless forgings are produced. Limitations: the dies must be considered stronger. The process is slower, requiring the more precision. Isothermal forging. In isothermal forging process, also known as the hot die forging, dies are heated at the same temperature at hot blank. In this way, cooling of the workpiece is eliminated. The low flow stress materials is maintained by the natural flow within the die cavity is improved. The dies are generally made up of the nickel alloys. Complex parts with good dimensional accuracy can be forged in is one stroke in hydraulic presses. Isothermal forging are generally is expensive, however it can be economical for initiate the forging expensive materials and large enough to justify the die cost. The sizing, coining, cold heating. The primary object is the sizing operations, closer dimension tolerances, and portion of forging. A plain sizing is the forging is pressed between the two flat dies. The operation of the slipknot forging enables accurate dimensions to be maintained to improve the surface finish. The three-dimensional sizing parts of the final size full operation in impression of the dies. Coining. The sizing operation is such that the metal flow is restricted in a space of the confined by the die impressions by the sizing operation is called coining. Sizing and coining operations are commonly due to the knuckle joint presses. The cold heating. The stock is the next die should be shifted to the blank to carry out the heating where required for the head is formed. Low points 3. The cold heating process is limited for the axisymmetric component from the combination of the extension offsetting techniques. The old forging is asymmetric component belonging to traces of the shaft components, flange components. It is provided to allow the metal for the closed dies. The connecting rod. The forging sequence involves the following steps. Then the First is to be initial forging stock, fillering, edging, bending, blocking, finishing. This is the forging sequence. The heated forging stock is first placed for the period for the eye inspection. Eye when it is fully hammer blow, then the hammer blow, then the edging of the impression is the to the metal before forging the stocks of the metal. Further 6 to be provided for the inches. The spite opens horizontally, remove the forgings on the pressure induce the metal flow is applied for the top core pin, which becomes the down and extrude the metals into the die cavity. One or the more mobile side cores or more advanced withdraw. This type of the tool permits the zero defect draft of undercuts as desired. Hammers, counter blow hammers, mechanical presses, screw presses, hydraulic presses, hammers. Hammers derive their energy, potential energy of the ram when this is then converted into the kinetic energy. These hammers are energy limited. The speeds of the hammer are high, therefore forming the timings of the minimized cooling of the hot forging, allowing the forging of the complex shafts of the particularly with the deep creases. The pin hammers, the power hammers, the highest is available 1200 kilojoules. Counter blow hammers, these hammers have to turns the simultaneously approach each other of the force the part. Generally the mechanical pneumatic, mechanical hydraulic type, the machines transmit the less vibration to the foundation than the other hammers. Mechanical press, these are the stroke limited press. These are either crank or eccentric type with speeds varying from the maximum at the center of the stroke to zero of the bottom. The force available depends upon the stroke positions and becomes extremely large at the bottom dead center positions. This proper sweep is essential to avoid the breaking dies of the other equipment. Screw presses, these presses are derive the energy from the flywheel. Forging load is transmitted through a vertical screw. These are the energy limited and are particularly suitable for producing the small quantity for the parts of recurring to precisions. Such turbine blades, the hydraulic presses, the presses have the constant low speed and load limited. The ram speed can be varied during the stroke. These are used for the both open die and closed die forging operations. The hydraulic press is about 700 meconewton. Generally, the presses are the aluminum, magnesium, beryllium, bronze, brass, hammers, copper, steels, titanium, refractory of alloys, switching. It is a matter of working press of cross-sectional area of bars and rods and tubes. The desired area is reduced by repeated blow readily actuated the sheep of the hammers. It is a batch process and not easily adaptable continuous process. Creep forming, this operation is the formation of the metal stress level below its yield point. The application of the heat to the metal sufficient to permit the metallurgical creep cause the relaxation of the elastic stresses. The deformation descent shape is achieved. The process is almost essentially comparatively shallow of the contour components. Hot isostatic pressing, the metal powder is treated the metal ceramic and container as the shape of the desired part. The container is placed the special pressure vessel and the compatibility of the simultaneously heating the container and subjecting the hydrostatic pressure. The power is compacted and densified and sintered in one step. Upon the removal of container, the finished pot closed to the final shape is obtained. This method is the food extrinsic material for the aircraft industries. Staking, it is the method of fastening two permanently. It is substitute for drilling, punching, and riveting. In this method, the shape is pumped forced into the top of the projections once the part of the to be fastened. This identations action of the punch deform the metal sufficiently. This keeps it tightly against the second component of firmly locked together. Precision blanking, the process produces the high dimensional accuracy of the edge of the pot along the entire punched surface. Fine blanking process requires completely good and dies with the zero, and the clearance between the punch and die is triple action of the process of the following actions: holding and metal firmly against the face of the die, embedding, wearing the pressure plate. This is also prevent the lateral movement and prevent the metal from flowing away from the punch as it enters. The blanking pressure, which remains the constant throughout the shearing stroke. The counter punch bucking against the blank punch is used for flattening, coining, bending, maybe the case. The perforating, it is the operations of the punching pattern holes in similar to the continuous rows. Bulging is the metal forming process explained to the tubular or cylindrical pot. Relatively, the symmetrical shapes can be provided for the mechanical means using the segmented bulging die, in which various segmented segments held together by spring and pushed apart punch in order to expand the supramised shell. In the other method of hydrostatic bulging, defects in rolling, the irregularities, it means the trapping of steel remain inside the flaps. Non-metallic inclusions, defects are produced especially during the rolling. Thick slab and crocodile cracks and separate the products into the two off and the internal blowholes in stock. It results in elongation of blowholes and product will become later. All of the above defects can be minimized by the careful inspection of billet and by keeping the roll smooth and clean to avoid the internal cracks. Defects in forgings, the scale pits, these are shallow depressions caused by hot removing scale from die scales subsequently walked into the surface of forgings. Mismatch occurs in dropping of the dies or correctly aligned results in lateral displacement between the portions of the forgings. Unfilled sections similar to the mesron in the castings occurs when the metal does not completely fill the die cavity. It is usually caused by using the insufficient metal or insufficient heating of metal. The defects of the resulting from the improper forging, much seams, cracks of the labs, etc. In cause of the defects, such pipes of the cracks, scabs, segregations, defects of resulting from the melting practice, such as dirt, slag, blowholes, defects resulting from the improper heating, the cooling of forging, burnt metal, decarbonized steel, and flakes. These defects are found all metals which heated the plastic steels and then shaped extrusion of the defects. The most common defect in extrusions from the back of the flow of the material, the pushing the end face of the billet into the core of the product. Such a defect weakens the products since the surface of layer is normally contaminated by the oxides. Sometimes heat is generated due to the extrusion maybe raise the temperature of the job, resulting in the development of surfaces of cracks or defects in drawing. The typical surface of the defects in rod and wire drawing are due to the bulging by hot particles and local breakdown of the lubricating film. The other kinds of defects are include the formation of bulge ahead of the die of the low reduction and high die angle and development of the center burst which with too large deformation gradient along the cross section. Deep drawing defects as insufficient blank holder, the pressure causes to develop the wrinkles on the flange, which may also extend to wall of cup. Too much of blank holder pressure and the friction may cause the thinning of walls and fracture at the flange, bottom and the corners due to the misplacement of stock. Unsymmetrical ranges flange may be results. The defect is commonly known as the misstrike. The effect of large grain size is to produce the dull surface. The defects is common reasons while drawing the rolled stock. Here the losses are because the adhesive to induce the rolling operations. Several operations needed to be carried out for the sheet metal work done by the hand or by some machines performed by either manually or by using the machines. The main operations is the measuring, the marking, cleaning, layout, hand cutting, hand forming, machine shading, nibbling, circle cutting, piercing, edge forming, joint making, bending, notching, drawing, soldering, sinking, racing, planishing, hollow blocking, the measuring and making the standard size of the metal sheet available in the market are quite large. The sheet is required for making the component may be much smaller, therefore it may be necessary to cut the required size of the component from the large sized sheet. The small size are first decided and then these sizes are marked for the large size later into the small size along the marked lines. While cutting the large sheets into the small size, the little allowance for cutting is always added to the required overall sizes so that the cut prices and are not undersized. Overall dimensions, length and breadth of required smaller pieces are marked on the large sheet with the help of marking tools including steel and straight edge, the steel square, etc. Scriber sheets have the coated with coloring media such as cellulose, lacquer, and scribed lines are clearly visible for producing the circular pieces. Divider of thermal cleaning invariably blank with the surfaces require the proper cleaning before the process. The recommend is more prominent in the case of the non-ferrous metal sheets like these copper, brass, silver, The surfaces are cleaned. Pickling the process, the pickle bath consisting of the one part of the turtle and the blanks or thorough washed stream water and allowed to dry. Sometimes cold pickling is used for the cleaning. The operations is not required very frequently. In such cases, usual pickling period is to be increased smaller acid to the water ratio. The pickle has to be used to ensure the effective cleaning of the surface, laying out the operation of scrubbing the development, the surface of component on sheet and sheet blank together with added the allowances of overlapping, bending, hammering, etc., which when cut out the blanks and folded and joined will give the decayed component is known as the laying out. Such layout when made on the sheet is called the pattern. In the case of the jobs to be made or small in size and large number, it is better to use of the template and repetitive for making the development and then cutting it along the marked quantities. The required allowances are included the template size, the cutting and shearing. The cutting and shearing operations are used to separate the sheet piece into the two parts along the pre-marked line contour. The cutting is normally used when the sheet metal is cut by means of the chisel hammer manually. The term of shearing extends the cutting sheets by the metal by the two parallel cutting edges of the opposite directions can be done either manually or by using the shear strips. The selection of particular cutting is dependent upon the thickness of the sheet metal, size of the blanks, amount cutting required for the to be done, number of the blanking or to be cut, the type of the productions available by means of the cutting, hand forming. This is the process of shaping and the bending sheets of the metal, the three dimensions into the desired shape of the size, and the final product is termed as the metal forming. The best example of the operation is the can be seen if one observes the traditional methods of the workers, the manufacturing, cooking, tensile and brass, blanks, hammering, shaping and into the different shapes and sizes without any joint. Machine shearing. Machine shearing is carried out by means of shearing machine. The shearing machines can be hand operated, built-in shear and form for continuous cutting along the straight line. The rotary shears are used. Nibbling. The process of continuous cutting along a contour which may be straight lines or irregular couples of known as the nibbling. The nibbling operations is carried out by the machine is known as the nibblers. These machines are portable shearing machines and can be either electrically or pneumatically operated. Circle cutting. The circle cutting is the operation of cutting the circular planks curved contours with the help of the circle cutting machine. It is the continuous cutting operations, piercing and planking. The piercing is basically hole punching of operation of blanking is an operation of cutting out the blank. In both cases, blanks will be produced. In the case of piercing operations, obtaining the blank is not objective. However, in the case of blanking operation, production of blank desired size of the main objectives, edge forming on and wiring. The edge sheet metal products are formed, folded to ensure the safety ends while handling these products and provide the stiffness of the or they will be retain the shape during the handling when still stronger edges are required. The metal wire or rod then forming the edge of by circling edge of the sheet metal around it. By doing so, not only the stiffness of joint increase, the appearance is also improved. Joint making for joining the sheet metal together, securing them the other metallic and non-metallic holes. Several means are used for include following: screwed fastening, riveting, welding, bracing, adhesives. The most commonly used methods involves for joining the sheet metal by means of the folded joint, class self-securing joints, followed by soldering, adhesive jointing, bending. The bending operations involves stressing of metal on outer surface of compressing the inner surface along the neutral line, which remains unchanged in length. The sheet metal can be bent by hammering over the base by hand by means of bending or rolling machines. Notching is the bent sections folded edge. There should be some provisions so that there is no overlapping of the metal corners and come together. In order to prevent bulging at such split, it is necessary to slit the clip of the metal or provide the small opening. The openings are the left at the corner, seams and edge are known as the notches, and operations is called notching. The size, locations, types of the shape of the object: straight notch, square notch, V notch, slant notch, wire notch. The drawing in sheet metal, the drawing operation is used for the producing the thin walled hollow shafts. The drawing operations is carried out with the help of the die, punch, suitable presses. If the drawn of the component of the width diameter, box drawing and shallow drawing, when the length of the drawn is more than the operation of the deep drawing. Soldering, the common method of joining the metals, which involves the spreading of low melting point alloy the molten conditions between the surfaces of the edges join and allowing the solidify. Here the sinking is the process of sink the bottom of for forming the tray of the flat rim. The firstly the position of the corner sinking is scribed of the depth of the tree and scribed inside dirt. A piece of the wood of the sharp corners is placed vertically, and in the vice over the edge of this metal beaten tree hammer the shape of the tree rising. It is the process of tinting the metal and raising the hammer of the mallet. Firstly, concentric circles are drawn the pencil compass and guide the key the work of the tool. The hammering is started from the center and worked around the circle till the outer edge is reached. The metal must be annealed after the completed the course, and process is repeated. Planation, it is the process which is applied the sheet of the main object stressing the metal with an improved surfaces. The process bring the article is the final shape and the parts some degree of the hardness of the metal. Hollowing or blacking, it is the process of beating the sheet of the metal particular shapes such as the source pan, lead or blowl, and it is used the The hollowing process may also done on the sandbag. The main advantages of the sandbag is that no indentions on the top. The elaborate that described very briefly commonly used machines in the sheet metal shop. Sheet metal working machines, when a large number of the jobs are to be made, particularly in the heavy types of the steel, it is obvious that hand operations like shearing, bending, etc., will be difficult to economical ends to carry out the job. Many hand operator as well as the powder operator machine have been developed. The shearing machines, folding machines, grooving machines, swaging machines, beading machines, universal cutting machines, burring machines, turning machines, wiring machines, shearing machines, shearing, plattering, round bar shearing, square bar shearing, angle iron cutting, folding machines. Folding machines are used for bending, folding for the edge of the plates and from the joint of at the stream. The bending machines or the bending rollers is known as the shaping metal sheets into the cylindrical objects. Grooving machines. The grooving machines is the groove as well as the positions can be conveniently adjusted. Switching machines. Switching machines is used for pressing, locking, grooved joints. Bending machines. Bending machines is used for bending operations. Universal machines. It is used for cutting the metallic sheets into the desired shapes and size. The machines to circular tools are used for circle cutting. The burring machines. The burring machines preparing the edges of the seam joint, the cylindrical shaped articles. The turning machines is used for making the round edge of the wiring operations. Wiring machines. The wiring machines is used for making the wire edges. Wire sheet is prepared in on turning machines in the sheet metal work according to the requirements of the many different types of the joints are used. A lump joint is very frequently used and can be prepared by means of soldering, riveting. Seam joint is very commonly used and the finish with the surface. A wide edge curve angular joints, flanched joints, making the pipe connections, cap joints provide the another useful locked of the same joints. The ruling is the forming operation of cylindrical section of the hot plate is reduced corresponding to increase the strength. Forging is a process of heated metal shaped of the application of the sudden borders of steady the pressure and characteristics of the plasticity of the material. Extrusion is the process of which the metal caused by the flow restricted, so creating the extremely elongated shape of the uniform comparatively small cross section. Winding is the process of reducing the diameter of the metal rods by drawing them through the conical openings in die blocks. Blanking is the process of cutting or shearing the blank form from the sheet of strip material. The spinning means the shaping of metal blank as it revolves at high speed in the lathe. Embossing is an operation of raising the surface of the component by means of pressing or squeezing actions. The casting means the pouring of metal into the molds where solidification occurs. Machining process of cold working the metal, different shapes and different types of the machine tools. Most important property of the plastic deformation by the mechanical working. The metal is plastic. The metal is said to be the cold work and crystallization temperature of the metal is cold working. Resistance stresses of the set during the hot and cold working or cold working, the sharp peening on the in the cold working operations, the plastic deformation of the metal carried out, the recrystallization temperature formed in the hot working. The hot working process is considered simultaneously combination of the cold working and annealing. Pipe welding is the hot welding operation. Hardening is eliminated in cold working operations. The hot working decreases the value of elongations. The reinforcement of crystals occurred in the hot working. In the cold working, the chances of crack propagation is more. In hot working, the internal resistance stresses are not produced. Rolling, casting, the forming of operation just in the cylindrical rolls. If 2 or 3, 4, 6 high rolls being least expensive or most common in the hot and cold working. The cold rolling is widely employed to produce the finished hot rolled metals. The cold rolling gives the improved surface finish. The cold rolling is produce the thickness of the dimensions for rolling the sheets. The coils, sheets or thousands of continuous mills are used. The steel is nearly always in the rolled by the hot finishing on the sheets. The brass, nickel and silver is usually the cold rolled with intermediate annealings. If the temperature is non-uniform, work hardening crack may be results. In the hot working, hot rolling crystal structure is refined. In the forging is the process which heated the metal shaped action of sudden blows steady the pressure. The flattener is used for the smooth finish of flat surfaces. The cage is used to cut the place to the curves. The drawing down the process is increasing the length of the bar and expense of cross-sectional area. The steam hammer works on the principles of the steam engine. The hooker is the cold extrusion process. About the 95% of the production impact extrusion collapsible. The indirect extrusions requires the less direct extrusions. The dimension tolerances of extrusions are very good. The wire drawing of the process reducing the diameter of the metal rods, drawing them through the conical openings. The blanking in the operations is the cutting and shading the strip material. The pierced holes should not be located to close adjacent holes. The spinning is the means the shaping of metal blank as it revolves. The high speed in lathe. The casting is the means the processing of molten metal and mold the solidification of the occurs. The die is the excellent surface finish of the dimension accuracy. The other methods is commonly methods include the precision of the chemical solutions, production of the fine metal machinings, vapor condensation. New development include the techniques based on the high temperature, exactly the metallurgical process. The metal powders are being produced using the high temperature process technique based on the reaction of the volatile edge with the liquids of the metal. Recent development includes the nano powder of the various metals, copper, aluminum, titanium, and the metals of the large plastic designations 5500 meganewton per meter square is reduced. The material enhance the properties blending of metal powders. The blending of metal powders to obtain the uniformity. Various processes may have the different sizes and shapes. To import the physical and mechanical properties and characters to the powder metrology product. Addition lubricants to the powders improve the flow characters of the powder. Such blends reduce the frictions between the metal particles, improve the flow of the powder metals into the dyes and longer dye life. In order to avoid the contaminations of the deteriorations of the powder mixing must be carried out under the controlled conditions. Metal powders like magnesium, titanium, zirconium, thorium powders, pressing or compaction of metal powders. The principles of object of pressing compacting is to effect of the cold pressure build between the particles so that some cohesion is conferred. This is usually measured by the strength of the green compact and termed as the green strength. Reduces the voids between the powder particles and increases the density of compact, reduces the adhesions of the cooled welding of powder and sufficient green strength. Plastically deforms the powder is the recrystallization during the subsequent heating. Plastically deformed by the powder to increase the contact and the areas between the powder particles, increasing the green strength and facilitating the subsequent sintering. The pressing and compacting carried out by pouring the measured amount of the metal powder into the die cavity and then the compacting the metal powder coherent of mass of more plunger, compressing the both the top and bottom. The compact is better. The compressing top only. The contribution of the distribution porosity of is more uniform to improve the uniformity of porosity through the the use of lubricants, graphite, stereostates and zinc, aluminum and lithium and stearate is made. The bond strength between the particles is affected by the area of contact and by cleanness of particles. The compacting pressure required depends upon the characters of the and shape of the particles. The methods of blending and lubrication. Pressure is required for pressuring the metal powders. Range of 70 meganewtons of the meter square of aluminum, 800 meganewtons per meter square. The compacting of powder in the steel dies at the room temperatures and the pressure from the 7.5 to 37.5 are employed. Mechanical presses are employed for the 500 kilonewtons and hydraulic presses for the high pressure molding of small parts. The great speeds at relatively low pressure can be best accomplished the mechanical press. However, the large parts and parts to be molded at high pressure are best molded in the hydraulic presses. Extremely hand powers, slower and more difficult to press. Some organic binder usually they require the hold all particles together after pressing the until heat of the sintering creates the atomic bonds and in hot pressing if the powder is heated in the proper proper temperature and pressure for complete densification is only 150 to 300 bar. Hot pressing requires dye materials having the appreciable eye strength, since even a study of dyes usually sustain only one operation before. Therefore, the art pressing is limited to the manufacture of articles of costly metals. Sintering. Sintering means the heating of pressed compact and to below the melting temperature of any constituent of the compact, at least below the melting temperature of all principal constituents, and increases the strength of the compact. Heating is carried out and controlled inertly on the reducing the atmosphere or vacuum or period oxidations. The period sintering, the compact brittle and its strength is known as the grain strength. Is low. The nature of strength and bond between the particles and hence sinter the material in compact. Recrystallization, grain growth and pre-shrinkages. During the sintering process, bonding of individual powder particles takes place in any of the following: the melting of minor constants, diffusions, mechanical bonding. The important factors of temperatures, time and furnace atmosphere. Sintering temperatures. The aluminum and aluminum alloys can be sintered the temperatures of 350 to 500 for the periods up to the 24 hours. Copper and copper alloys can be sintered at the temperatures of ranging from 700 degrees centigrade. Temperatures that may be melt one of the constant metal. The compacts of non-powders are usually sintered at temperatures of 100,000 degree to 1200 degrees centigrade. During the sintering, ordinarily density of compact is increased and shrinkage results. The shrinkage fills holes within the compact and increases the area of the contact, reduces the size of the holes and compact. The shrinkages can be controlled carefully. Then the selection of metal powders, determinations of the correct pressure and cold forming instances are also meet the pressed compacts. During the sintering of this caused by gas being trapped within the compact during the pressing or producing the chemical reactions of the compact. Sintering may be carried out on the batches on continuously in batch type, continuous furnaces respectively. Batch type furnaces improve the usual laboratory experimental work, while continuous furnaces more suitable for production work. Continuous furnace usually compresses the three zone. First zone warms the pressed parts and protective atmosphere is used in the furnace and purges the work of any air oxygens that may be carried into the furnace by work trees. In second zone, work is heated to the proper sintering temperatures. The third zone cools the work to temperatures, allows handling the finishing operations after sintering. Following the additional operations may be carried out to the further improve the properties of the powder metallurgy products. Reprocessing. The purposes of these operations is dimension accuracies to sinter a part and to improve the part of the strength and surface finish by additional densifications. The forging this process involves the use of unsintered and sintered alloy powder performs that are subsequently hard forged and in heater confined the dies to desired final shapes, and performs may be helped the also shaped by impactly forging. The process is usually referred to as powder metallurgy forging, and when performing the sinter, the process is usually referred to the sinter forging. Infiltrations in this process, the metal slag is to be lower melting point than that of the pot is placed against the sintered pot, and the assembly is heated at the temperature of sufficient to melt the slag. The molten metal infiltrates of the porous by capillary actions, resulting the relatively pre-free the good density of distant powdered metal pots, and the operations including heat treating, machining and finishing. Design consideration of the powder metallurgy in order to facilitate easy ejections. Narrow development sections should be widened as far as possible. The abrupt of the changes in actions thickness should be widened in order to increase the tool and die life, reduce the production cost. Powder metallurgy parts should be made with widest dimensional tolerances consistent with their intended applications. In designing of flat sections of high density enough sections thickness should be provided, otherwise the punch will be break under the pressure. The design should be consistent with the capability and limitations of available equipment. Very close dimensional tolerances in the direction of processing should be avoided. The design of dimensions of the part should be carry the adequate allowances to compensate for likely changing in dimensions due to the sinkages during the sintering. Wool should not be designed in the direction of pressings. The production of very small holes through pressing should be preferably be avoided. The wall should not be less than the 1.5 mm thick, although the walls as thin of 0.34 mm have been successfully provided the components of the 1 mm in length. The walls with length to thickness ratio greater than 8:1 and difficulty to press. The density of variations are virtually unavoidable. The meeting plane between the molding punches should be on the flat of the cylindrical surface and never the spherical surface. The dimensional tolerances sinter the powder metallurgy pots are usually of order of 0.05 to 0.1 mm. The tolerance improves significantly with additional operations such as sizing, machining and grinding. Die and punch surfaces must be tapered and polished. Directions and tool movements must be improved. The die life overall the performance overall performance. Thank you. We'll see in next video.